All right, let's talk about architecting security. In this explainer, we're going to break down exactly how you can build a robust, automated security shield directly into your CI/CD pipeline. We're going to transform security from a roadblock into a runway for faster, safer deployments on AWS.
Let's just start with a fundamental truth that I think every single one of us knows deep down. Finding a security flaw after you've already deployed to production, well, it's a complete nightmare. It costs a ton of money, it burns time, and it just tanks team morale. Our whole goal here today is to prevent that nightmare from ever happening in the first place.
For so many years, security was treated like this final, painful wall you'd slam into right before launch. You know the drill, right? It was a totally separate team, a whole different process, and honestly, a massive bottleneck. That old model is just fundamentally broken for how we build software today.
So this is the real shift in thinking we need to embrace. We are moving away from what I call the wall of no, that slow, manual gatekeeper that everybody dreads. And instead, we're architecting an intelligent shield, something automated, fast, and just woven right into the fabric of the development workflow.
Okay, so let's really dive into this new model. I think the best way to understand it is to just follow a single piece of code on its journey right from the moment a developer hits commit and sends it into the repository.
Now, this entire journey, this whole philosophy, is powered by one core principle: shifting left. And it's a beautifully simple but incredibly powerful idea. It just means finding and fixing security issues as early as you possibly can in the process, because that's when they're the cheapest and the easiest to resolve. So our piece of code now enters the CI/CD pipeline. And I want you to think of this pipeline as more than just a build tool. Think of it as a gauntlet, an automated gauntlet of security checks. And to make it to production, our code has to prove it's worthy by passing every single one of these gates.
The second that code gets committed, the gauntlet begins. First up, the pipeline runs all the foundational stuff: unit tests, integration tests. But then, right away, the code itself gets put under the microscope with something called Static Application Security Testing, or SAST. This tool scans the source code directly. It's kind of like a spell checker, but for security, hunting for common mistakes before the app is even built.
But here's a crucial point. We're not just scanning the code we wrote. We're also checking all the building blocks we didn't write, all those third-party dependencies, to see if they have any known vulnerabilities. And at the exact same time, we're scanning our infrastructure as code, the blueprints for our cloud environment, to make sure the very foundation we're deploying on is secure and compliant from the get-go.
Okay, so after all of those checks on the source code, we finally build the thing we're actually going to deploy. In this case, a container image. But we're not done yet. We perform one last deep scan on that final image, checking every single one of its layers for known issues before it's even allowed to be considered for deployment.
And what happens when one of these tools finds something really bad, a high-severity issue? Well, the process just stops. Bam, dead in its tracks. The build fails, and it fails automatically. And this, right here, illustrates the entire point. A pipeline halt isn't a failure of the system. It is the shield working exactly as we designed it to. It physically prevents a vulnerability from ever reaching production, and it gives immediate, actionable feedback straight to the developer, right at the moment when it's cheapest and fastest to fix. It's beautiful. Now, as an architect, just implementing these automated gates is really only half the battle. This is where the core challenge you have to solve comes in. How do you balance this robust security with the absolute need for developer productivity and speed? There's a term for this potential downside, and it's developer friction. Look, if your security shield is too slow, or if it's too noisy with false positives, or just too complicated, your developers are going to get frustrated. And let's be honest, a frustrated developer will always find a way to work around the shield.
So this really is the fundamental question for you as the architect, isn't it? How do you design a system that actually protects the organization without accidentally trapping your developers in a cage of slow builds and really confusing security alerts?
Your goal is to find that sweet spot, that perfect balance. It's a state you can call secure velocity. This is the dream, right? It's where the shield is incredibly strong and effective, but it's also so fast and so well integrated that it feels almost invisible in a developer's day-to-day workflow.
So that all sounds great, but how do you actually get started? Let's get practical and look at a blueprint that you can use to architect the very first version of your automated security shield. We call this the minimum viable shield. Think of it as a non-negotiable starter kit with 4 automated checks. You've got SAST for your code,
You have software composition analysis, or SCA, to scan your open source dependencies. You have secret detection to find any leaked credentials. And you have IAC linting to check your infrastructure blueprints. This set right here gives you a fantastic security baseline for literally any pipeline.
And the strategy is so simple. You start right here with this solid foundation. You make sure that every single one of these checks is 100% automated from day one. And then, over time, you evolve your shield intelligently, adding more layers and more sophisticated checks as your team and your applications mature.
So as we wrap this up, I want you to think about your own environments, your own pipelines. What's the one immediate, high-impact check that you could automate right now? What's the very first layer of the shield that you're going to start architecting tomorrow?